Hey there, Tony again from Empower Me First. So let's pick up where we left off. We have two different drivers who charge according to a different price scheme that translates into two different equations that we have here. And the mission ahead of us is to identify which driver to call anytime you need a ride. We want to do a couple of calculations that enable us to derive conclusions for any distance we might want to ride with any of these two drivers. We're using the example of cab drivers here, but the interest of this kind of approach is that it can be used in countless real-life situations. Like, for instance, if you want to choose between two carriers when you're buying cell phone data, or if you have a business and you want to choose between suppliers, and so on. All right, but for now, let's focus on our two drivers. Let's dive into it. The way to approach this is take these two equations and set them equal to each other. Let's do that. So here we have the first equation, and we said we wanted it to be equal to the second equation. So let's write the second equation next to it with an equal sign in between. Here we go. So this means that the price for this equation is going to be equal to the price for this equation. The question we are trying to answer is for which distance the two drivers charge the same. So we are going to leave the P out for now and focus on D. Explaining why we can do that would be too much of a tangent right now, so I'll get back to it in a minute. We are solving for distance, so let's put all the D's on one side and all the non-D's also together on the same side. As you can see here, the plus 2.5 became minus 2.5 for the D's, and the plus 3.5 that we have here became minus 3.5. This is something we covered already, but just a quick reminder in case it is necessary. What we do when we remove the 2.50D to take it to the other side, what we are actually doing is a subtraction. We are subtracting 2.5D or 2.50. 2.5 and 2.50 is the same. So now, since we have the equal sign here, we need also, for this equal sign to remain true, to subtract the 2.50D, the 2.5D on the other side. And here we have a plus sign in front of the 3.50. This was always positive, right? So this explains why on the second line here, when we have the 2.50, it is negative because it has disappeared from the other side. And the same applies to this 3.50 that is positive that we take to the other side with a minus sign. This is what we have here. If this is still not clear, you can check earlier videos that explain this in more detail. Anyways, back to solving the equation, we have 3D minus 2.5D gives us 0.5D, and this is equal to 6 minus 3.5, which gives 2.50 or just 2.5. This 0.5 here means that we have half a D. We are solving for D, so our goal here is not to have 0.5 or to have 3 or whatever. We just want 1D or just D by itself, right? D equals 1D. These two are the same. So what we do to go from half a D to 1D is we multiply by 2. 2 halves equals 1. If you have 2 halves of a pizza, you put them together, you get 1 pizza, right? Okay, now we have our D on the left side. And remember, for the equation to remain true, if we did one operation on one side, we need to do the same operation on the other side. So we need also to multiply the 2.5 by 2, which gives us 5. D equals 5. So what we just did is figure out for which distance Sheldon and Leonard will charge the same price. Remember, D corresponds to the distance in miles. Earlier, we left out P. We could do that because we knew that both equations, this one and this one, they were both equal to P. This is what these two equations say. In other words, if both equations are equal to P, it means they are also equal to each other. So when we left out P here, we did not remove any information. And because we did not remove any information, we could leave it out. And the fact that we left P out just means that we don't know the price of the ride until we put it back into the equation. So we figured out first the distance for which the price of the ride was going to be the same between the two drivers. Now that we found our D, we can substitute this D with that number 5. into any of these two original equations, and once we do that, we will figure out the price for a 5-mile ride with any of these two drivers. So let's plug our D into Sheldon's equation, and this is what we get: a price of $18.50 for 5 miles. So at this point, if we want to figure out the price, we're done. No need to do it with Leonard, since we know it will give us the same price. But since it is our first time, let's do it to show that it is indeed the case. And indeed, his price for a 5-mile ride is also $18.50. So in this video, we'll learn how to calculate the distance at which you would be indifferent between the two options. To do that, we set the two equations equal to each other. We left P out and we solve for D. If we want to figure out the price, we need to take the value we found for D and plug it into any of these two equations. So here we did it with Sheldon and we found the price. And at this stage, we know how much is the price for this value here that we identified for D. And basically, we're done. And just to drive the point home, we also plug this 5 again in Leonard's equation, and we found the same value of 18.5 for P. Thinking about our mission of identifying which driver to call anytime you need a ride, we're halfway there. We still need to figure out who is cheaper if we want to ride for a different distance, a distance that is not equal to 5 miles. After what we did now, it should be quite straightforward. Let's do that in the next video.